So the only homework you'll have for Saturday is going to be section 2.6. Then next week, you will work on chapter 4. So have chapter 4 ready. We did 3 and 5, now I'll do 2 and 4 in this test. I'm looking to have a test on Thursday the 12th. That looks to be the day that your test will be. So we should have 3 days of chapter 4 and today of section 2.6, and then that will conclude the unit 3. Then we will have chapters, just kind of giving you a heads up, you'll have chapters 6 and 7 together for unit 4. So you'll have 2 and 4 for this next test, which is tentatively scheduled for November 12th. Yeah, I think that's the Thursday, November 12th. Yeah, and then the last 2 weeks we'll talk about 6 and 7, and then you'll have your unit 4 exam Thursday, December 3rd. So if you wanted to keep that in mind, that's tentatively what we have for exams, and then we have the final exam. So you have 2 big exams left on the final, and a few quizzes here and there. So let's take attendance. I have Adam here. If I don't say your name, let me know. I've got Alex Archer here, Tony, Larry, Keith, Pat, did I miss anybody? That's everybody today. All right, so start in. You should be on slide 49. Now I want to have your calculator ready to go. I don't think you need extra paper today. I think you'll be okay with the space I've provided you. But it wouldn't hurt to have, if you have your unit conversions paper way back, it was this handout that you might have had to print. If not, I'm gonna just have it available for you or talk about it. So I think what you have is just your PowerPoint packet would be enough for today. Okay, so finding my pen. Let's go ahead and start in. So we're talking about solid geometric figures. These are going to be 3-dimensional figures. And a lot of times when we talk about 3D figures, we're talking volume. We discuss volume a lot. And volume is the measure of space occupied by a solid geometric figure. Those units used for volume are going to be cubic units. Cubic units. So you have about feet cubed, inches cubed, mile. We probably wouldn't talk about miles cubed too frequently, but millimeters cubed. Lots of different units that we can cube. So we're talking about having 3 dimensions. Now, also on a 3D figure, we'll talk about the different types of figures. We also discuss surface area. So although it might be a 3D figure, we talk about just the area, which would be area of all the faces of all the solid the geometric figure, total area of all the faces, and those would be in square units because we're talking area. We're covering it, we're not filling it. And I want to back up with volume. Sometimes we have units that represent volume, like gallons. You don't cube, but you're cubing measurements for length is what we would be cubing here, but we might actually have a unit that would give us volume that would not require, like liters would be another one. We wouldn't have to cube liters. That's a volume unit. All right, then lateral surface area down here. Lateral means just the total area of the lateral faces, not including your base. And we'll discuss what I mean by the base, but this is also an area unit, so it's going to be square units as well here. Right, let's move on to our figures. These are really hard to see. I'm looking at the printed PowerPoint and it's small and it's not even all that great here, but I'll try to mention what they're labeled. So if you're looking at this first figure that I'm kind of referring to, this is called a rectangular prism. Rectangular prism. Also known as a rectangular solid. I'll put it in parentheses over here. Rectangular prism, what does prism mean? Well, prism is referring to the bases. So we have a base down here, it's pretty easy. And then there's what we wouldn't necessarily call the top is also known as a base. If those are parallel to each other, we have a prism. So I'm just going to put in parentheses here, we have parallel bases. It's a prism. Okay, then the labels that are hard to read, and if you need me to stop, I can't see anybody's face right now. I've got you hidden apparently, and I've got myself hidden. If anyone has any questions or any comments, or if I make any mistakes, cut me off or ask me a question at any time. So we have L, W, and H here. Length, width, and height is the measurements that we have on this diagram. Now coming down to the next one here, this is a cube. It's also a prism. It's a rectangular prism, but it's a very specific one. It has the sides are all the same. So the label on this one is an E for edge, and all of these would have E. These would all measure to be E, every single one. All right, and here we have a right circular cylinder. A right circular cylinder here. We also have parallel bases. And we have a circle for a base. So we have this circle here, and then we have an H for our height. So we have the measurements labeled that we would need to find volume or surface area on this figure. R, or the radius. So you see that I have an R there. And then the height is H right here. Right, the next one I have here, you'll notice, let's see, our base is 1, 2, 3, 4, 5, 6. I think I didn't count. No, yeah, 1, 2, 3, 4, 5, 6. I missed something. So we have 6. So it has a hexagonal base, right? Or this could be 8 or anything like that. So we have a right, it's perpendicular there, right polygonal prism. Multi-sides here, polygonal prism. And when we say right circular cone, we also have it's perpendicular there as well. Okay, a right circular cone. My pen just keeps freezing. I don't know. Is my screen freezing? Am I freezing or cutting out?
So far, no.
You can hear me okay? I don't know what's going on today. My computer is just, okay. Just need to catch up. This is bizarre. So a right circular cone. And taking a look at these labels, they're very tiny on your handout. So here's the radius. We have this label that's R. I'll write over it so you can see R. Then this here is a perpendicular to the base. So this from the vertex of this cone to the base is perpendicular, and we have a height. And then we have this measurement here on the outside of the cone, which is known as S. I'll use S. One might look like a 5. It's for the slant. So think about that side here being S. And you'll notice that there's this right triangle that's formed in here, and that's very helpful in a lot of our application problems because then we can use Pythagorean theorem to help us solve for either a leg or a hypotenuse. So we can either solve for the radius or the height or the slant side, depending on what we're given. So again, that's an S, not a 5. I'm going to pop down over here. This is called a square pyramid. So we have a square, when I say square pyramid, we have a square base. And all you really need to have measured is the height, which is the perpendicular from the vertex all the way down to the base. It's going to create a perpendicular, I guess it's going to make a right angle, I should say. It's perpendicular. And you can calculate this dotted line I just put in there. So you don't need to be given the radius, but you could calculate it given the height and given the slant. So you'll see this the slant again, this S is the outside from the vertex all the way to the outside of the base. And that is represented by F5, but an S. And then we have that H here. And then you can find R. So this would be an R, or you could say it's not really a radius. It could be something else. You can call it X if you'd like, any measurement. I'll stick away from, I was using R originally, but I'm not going to there because R usually means a radius and this is a square base. So just call it X if you wanted to, but you don't need it. You can always calculate it given H and S using, again, Pythagorean theorem, because you can see this nice right triangle that's created. So then the last figure we have is a sphere. And on a sphere, you really only need the radius measurement. So you only need an R. So I've got that there. Any questions on our figures? Now, do you have, yep, okay. So I'm glad I didn't write over it completely. So I have a cone within a cylinder here to represent what's happening. So if you have, let's pretend that this figure here, this cone has the same base as this right circular cylinder here. So if they have the same base, the cone would fit right in, let's say, and they have the same height. And the cone, if you were filling it, again, volume is how much space an object can take up or filling it. A cone is a third of the cylinder, of a comparable cylinder. So a base, the same height, cone will take up a third of the volume of a similar cylinder. And we'll see that in our formula. So let's move to the next slide, which has all of our formulas all in one space. It's quite hefty. I mean, we've got a lot right here, but it's nice because when we need to look for certain formulas, you can come to this slide and it will be helpful. And the beautiful thing about remote learning is I'm never taking away your notes from you when you're taking an exam. So gone are the days having to memorize this for at least this semester. And as you probably know, and I'll make a mention of it now, 205, most of you are headed on to 205, correct? Some of you might not need to. Who's headed to 205? Anybody on this call?
I am.
Okay. Now that's also going to be remote in the spring. You've heard our classes will be remote in the spring, most likely. I've got a couple chats here. Let me see what else has been chatted in. Larry, no? You don't believe so, huh?
I don't know what I'll have.
That's okay. So I'll just pause before I get into these formulas and I'll talk about a little bit about next semester. So the schedule is up on the web, the spring 21 schedule. It's up on the web so you can check what times of day things are offered. Now, a lot of you in the tech fields, obviously you're in Math 105 for a reason, usually just because it fits in your schedule or because you just love math. So your tech programs might have some face-to-face or on-campus components to it. Again, like it did this semester, or it might be completely remote. So you can see on the schedule under the room, you'll see if it's remote or not. And if it has a room listed and has times, and you know you probably have to attend at some point in time on those days. So Math 205 would be the next class most of you would take in your degree program, and it will be remote as well as this class for the spring. So in your whole math career for the rest of your time here at Clinton, you probably won't have to take a test without your notes. So anyway, I don't know why I brought that up, but I did anyway. So coming back to our formulas. Now, a lot of these Yeah, I have memorized because I use them so much, but they're also somewhat intuitive. When you start getting a hang of it, you're saying, okay, well, I have this formula for a general right prism. I didn't say it was, a rectangular prism. I didn't say it was a cube. I didn't say it was anything else, but the prism would have, again, the parallel bases, like the top and the bottom would be parallel. And to find the volume, we have this big B times H. And this allows for us to say, well, if it was a rectangular prism, you take the area of the base. So big B, this is different than the little b. The big B is the area of the base, and you're going to multiply it by the height. Since if they're parallel, they're going to stay the same distance or equally distant across the whole prism. So you'd be able to just take your base times your height, your big B area times your height. And that's true. You could do this with a cylinder, a right circular cylinder could fit under here, although we have a very specific formula here because we do know that base is a circle, but it would fit here if you found the area of that base and multiply it by the height. Same thing for the right polygonal prism, the cube, rectangular prism, those all fit in here. Although again, we have some very specific ones for these first three here could all really be under this formula. So for volume anyway, so volume for a rectangular prism is going to be the length times the width times the height. So if you look back at your diagram on the last slide, maybe your length times your width times your height would be your volume. Now for the surface area, let's go over here for a second. The surface area is talking about, basically, I think about painting the outside of this prism or wrapping paper without, with neglecting waste. So this surface, we have how many sides? If you count up your sides, you have the base and you have the top, or the two bases, you can call them both bases. And then you have the four sides. So you have 6 total sides. And if I think about, without memorizing a formula, if I wanted to find the area of this one that I'm kind of shading in, this front, it would be the length times the height. And then of course the back has the same, it would be length times the height. So we have 2 of those. And then if I come to the side here, I'd have W times H. And I know over here would also be W times H, so I have 2 of those. And then my base, I don't think I did my base yet, which is here, it would be L times W. And then it would be the same up here, L times W. So 2 of those. So looking on the last, gosh, everything is working so slow. I don't understand. I have 2 times my length and width plus 2 times my length and my height plus 2 times my W and my height, my width and my height, as I mentioned. Cube, volume, you're going to be, it still fits under the rectangular prism. You could use length, width times height, but because it's a cube, you can just take one side and cube it. And then, oh my goodness, I don't know why I went backward, but okay. So if I talk about the surface area of a cube, I guess I wanted to be here anyway. There are still 6 sides of a cube. So if I went with the front side here, this is going to be E times E. And if I went with the side on the right here, would be E times E, so it's E squared. And then the back would be E times E with E squared. This left side would be E squared. Bottom's going to be E squared. So there's 6 of those. So when you see the lateral surface area formula, you'll see that it's 6E squared. I shouldn't say lateral, I meant surface area. Specifically just the sides and not the bases. So I misspoke there. Surface area, talking about all the sides. Right, circular cylinder. Well, your base is going to be pi r squared. So here we are, pi r squared, and then multiply it times the height. And then if we wanted to find the surface area, not lateral surface area, but surface area, we're talking the base. Base's area would be pi r squared. The top right here would be pi r squared. So that's 2 of those. And then you'd also want to have the outside here, and we find that, let's take a look at our formula here. We have 2 pi r h. This is saying take the circumference times the height. So that's the formula there. And you can, if you can come up with that without having to look at it, that's good too, because that's also something you can just count. You just intuitively use, your knowledge of area to calculate it, or you can use the formula. Right, circular cone. Remember I told you for volume, a cone, if you had a similar cylinder, the volume's 1/3 of that cylinder. So you see that 1/3 in front of it, and it'd be the pi r squared h. So you're 1/3 of your base times your height, your big B. And then the Surface area is the area of the base. So a cone only has one base. So we have pi r squared, that would be a circle base, and then plus pi r s, where s is the slant. And that will find you the surface area together. Square pyramid. So square pyramid right here, where we have a square base, but it's a pyramid coming up. So we have the formula to be a third of the big B times H. So this is going to be a third of what we would say maybe the right prism that it would match, the rectangular prism that would be corresponding. Then the surface area here, this one looks kind of hideous, this formula, not so friendly, but it's not that bad. So the area for the surface area, you really need to add up the surface area, the area of the base. Well, that's easy, right? Because it's going to be whatever this side is times this side. So the area of that base, we can just call it big B for that area for the base. And then you have four sides. You have four triangles. You're adding up their areas. So you'll see that we have 4 times 1/2 base times height. Now a base times a slant. So the base here is a little b. So whatever that base is on that triangle, and then the slant times the slant. So that would give us that height of that triangle on one side here. So you have this times this, and you want 1/2 of that 4 times. So we can simplify that formula to be 2bs instead of having 4 times 1/2. And then when I say the big B, remember it was B times B, because we would label this as this side as B, lowercase b. And then the sphere. This one, when my students get to calculus, they've already forgotten what a volume of a sphere formula is. So volume is 4/3 pi r cubed. All you need is that radius labeled on that sphere to find the volume. And then if you were going to paint a sphere, find the area of that sphere, your formula would be 4 pi r squared. Okay, so I think I might have misspoke by accident. It was totally accident, kind of confusing with my technology here, but all this right column is only surface area, not lateral surface area. Lateral surface area does not include the bases. But when I'm talking about total surface area, we are including the bases, and every one of these formulas does include the area of the base or bases, depending if it has one or more. Let's start in with some examples. And this one is a lot of fun because there's a lot of things involved in this one, so bear with me, stick with me. So during a rainfall of 1 inch, so 1 inch rainfall, what weight of water falls on an area of 1 square mile? And then we're given each cubic foot weighs 62.4 pounds. So figuring out what I'm trying to find, it says what weight of water, so I'm going to say we don't know the weight, falls on an area that's 1 square mile, and it's an inch of rain. So we're talking of, if you think about a square mile, so it's going to be like your base is going to be 1 mile by 1 mile, potentially, whatever comes up with 1 square mile. You could have a couple, like a 1/2 square mile, 1/2 mile by 2 miles, but let's just say 1 square mile. That's going to be our base. I'm going to use capital B on purpose. So if I want to find the volume of this, is going to be big B times H, where B right here, this 1 square mile is going to be the area of my base, and my height, do you know what my height is from this problem? Yes, Larry, it's 1 inch. So we have our height to be 1 inch. Good, so height is 1 inch. Now, if I'm looking at this problem, I've got miles and inches in the same problem. So I don't want to be taking, let me set this up, I guess. So if I take the 1 square mile, 1 square mile, and then I have my 1 inch. And you know what, I'm going to put that square inside the parenthesis, although it's fine the way it is, because of that 1 is fine, but I don't want to be confusing. So square miles here. We don't want to be dealing with miles and inches. So, and I'll deal with this in a minute. I will deal with that in a minute. So miles and inches, I can put everything in miles, put everything in inches, put some, everything else in another measurement. And if I'm thinking about my goal, my ultimate goal is to find the weight. And we're given this little piece of information here. Oh my goodness. My pen here. 1 cubic foot equals 62.4 pounds. So in this measurement here, it's using feet. So why don't I just go ahead and get my volume in terms of feet? So I can have cubic feet and then I can convert it into pounds. All right, so what I'll do is I'll change this 1 square mile into feet. Does anyone know, or does anyone have that table, the common equivalents available? Does anyone know how many feet are in 1 mile?
5,280.
You got it. So 1 mile is 5,280 feet. And a lot of us know this for different reasons. You might have known this without being in a math class because whatever you're doing outside, whatever hobby you have or any, job you might have, you might already know this. Now inches, how many inches in a foot?
No, yeah, that one's 12.
Yeah, 12 inches.
Most people should know that.
Yeah, right. This is going to be something you shouldn't have to look up. So 12 inches is 1 foot. You could also say 1 inch equals 1/12 of a foot. So however you want to think of it, whatever makes more sense to you. So I've got both of those up there plus the mile. This one you might not know so well, but you could look that up easily. You might have heard it and said, oh yeah, that's right. All right, so if I'm converting square miles, I have only 1 mile. I don't have a square mile. So if I want square miles, I have to also square this. So when I'm down here, I am going to convert. So like I said, 1 square mile would be 5,280 feet, that quantity squared. So if I square the mile, that's going to be equal to 5,280 feet squared. So I got to square both. This time I do want the exponent on the outside because I'm squaring the whole thing. I'm squaring the 5,280 plus I'm squaring the units feet. All right, then times 1 inch. 1 inch is 1/12 of a foot, so I'm going to replace it as 1/12 of a foot. All right, so when I square 5,280, let's get my calculator. I think I can get that out. Can you see my calculator? Sticking on my whole screen, if you can see it. So 5,280, I'm going to square it, and then I'm going to multiply it by 1/12. So I can divide by 12 is the same thing. So you can either multiply by 1/12 or divide. I get this number here, so 2,323,200. So 2,323,200 cubic feet. We squared the feet here. We have 1 foot here. So square feet times feet would give me cubic feet. I could also write this in scientific notation, and I'll use 3 significant digits here. I almost feel like there's an earthquake going on right here. Okay. Anyone feeling anything? All right, I'm losing my mind today. 10 to what power? Anybody? I converted this to scientific notation. Maybe 3/6.
Yeah, it looks like Larry said it was 6.
Oh, sorry, my chat's on my other screen and I'm Okay, got it. Didn't pop up on my other screen. Got it. So 2.32 times 10 to the 6. That you could use either number. I don't care if you use it in scientific notation or if you use the 2,323,200, but we're using 3 significant digits, so we're good. So no one felt any tremor. All right.
No, definitely not.
Okay. Most shook for whatever reason. All right, moving on. So that's a volume. What is our goal? Our goal is to get the weight. So we have the cubic feet, and we know that each cubic foot weighs 62.4 pounds. So what we can set this up as for our weight will be the 2.32. I'll use the scientific notation because I haven't done it in a while with you. Times 10 to the 6 cubic feet, and then times our conversion. So if I want to get rid of feet and I want to be left with pounds, I'm going to write this as a unit conversion factor. So I'll write it as 62.4 pounds over 1 cubic foot. So when I do that, cubic feet would cancel, and you would have 2.32 times 10 to the 6 times 62.4. Let's do that on the calculator. And then with scientific notation, you can write it as 10 and then to the 6. Times 62.4. Or to make it easier, I could do 2.32. I mean, it depends what you feel comfortable doing. You can do the 2.32 times the 62.4. And then you can put that into scientific notation. And then you can multiply that by 10 to the 6. So this would be 1.44 times, so if I went with this one here, it'd be 1.44, 1.45, I should say, times 10 to the 2nd times 10 to the 6. Or instead of confusing you, we already got it to be 1.45 1.45, and then it was times 10 to what power? Right here, this number right here, we have 3, 6, 7, 8. So we times 10 to the 8th power. And our units here will be in pounds. All right, so that's in pounds, so it'd be 1.45 times 10 to the 8th in pounds. You could also write this, I didn't say what unit of measurement to give it in, but pounds is what we were using as the conversion, so this was fine. So this would be a completely correct answer. But if I wanted to go a little bit further and say, well, that's a lot of pounds, let me convert that to tons. How many pounds in a ton? Yes, 2,000 pounds equals 1 ton. So if I want to use that for my weight, so I have the 1.45 times 10 to the 8th pounds. I can multiply that by the conversion factor of 1 ton to 2,000 pounds. Pounds will cancel, so I'm taking this number and dividing it by 2,000. Using my handy calculator here, so 1 divided by 2,000. I get 72,000. Or I might want to, I already rounded this. So you might get this 72,384, but I also used this. I had this exactly here. I should probably use what I had written down, which is 1.45 times 10 to the 8th, and then I'll divide that by 2,000. And we get about 720. Oh, is that too much? 2,000, sorry. That's 72,500. Tons. So these are the same. That's a lot. We're talking an inch of water over a square mile will weigh 72,500 tons. It's a lot. I don't know if it's mind-boggling to you or not, but I think it's a lot. All right, so next problems are not as fun. I think that one was probably our most fun for the day. Fun meaning a lot of work involved, a lot of complex problems. Like we had some I wouldn't say complex, but we had some conversions, lots of conversions, trying to represent it in a usable format. So that was kind of interesting. These are a little more straightforward. So a paper cup is in the shape of a cone as shown. What is the lateral surface area of the cup? So I have lateral here because we don't need the area of the space because there's no cover on this cone. So think about those snow cones that come in those paper cups. This is what we're talking about. So if you can't, I think you can read this okay on your print, but it's 3.6 inches across here. That would refer to a diameter. And then we have a height that is 4.5 inches. So the height would also be the same from here to the vertex. So just that it's easier to draw it on the outside than it is to draw it like through the diagram. So we have that labeled as 4.5 inches here. So if you want lateral surface area of a cone, let's go back to our slide here that had our formulas. A right circular cone, our surface area, not lateral, but our surface area was all of this. Now remember, the pi r squared was the base, and if we want lateral, we just want the outside here, paper part of it, which is the pi r s. So that is going to be our lateral surface area if we take away the base. So the lateral area will be pi r s, and I'm using a cursive s because my s's look like 5s. All right, so I'm going to need my radius. Well, I don't have it, but I can certainly find it. I said that we had our diameter was 3.60 inches. So our radius would be half that, which would be 1.80 inches. So from here to here would be 1.80 inches. And then our S, remember, is the slant. So this right here, the 4.5 is the height, but I want this, I want that S. Well, I can find it if I think about this right triangle that is formed with this and then the height. Now the height has been labeled, like I said, outside of the diagram, but really this 4.5 is the same here. So we have 1.8 across here. We have 4.5 for the height. So using Pythagorean theorem, I can find the slant. So if I'm going to take this triangle and I'm going to draw it down here. So find S. And this right here on the side would be 1.80. This is going to be 4.50. You can leave off the zeros for now, but just remember you had 3. So if you caught 1.8 and caught 4.5 for now. So when we're squaring it, so using our Pythagorean theorem, it's going to be the hypotenuse squared is equal to the leg squared plus the other leg squared. And again, I'm going to leave off the zeros for now, but I know I'm using 3 significant digits there. So 1.8 squared plus 4.5 squared. If I type that in my calculator, I'm going to get S squared is equal to 23.49. So I'll show you. So this is 1.8 squared, then plus 4.5 squared. 23.49. Now I want the square. That was s squared. I want the square root of that. So square root. And I'm going to do second answer, which is above the, oh, I don't know why I did that. Second negative sign, which is answer. So it's going to take and give me the, no, I do want the square root of the answer. Second answer. There we go. And enter. 4.85, round to 3 significant digits there. So 4.85. S is equal to 4.85. Now there would be a positive and a negative when you actually take the square root, but because we're talking about a measurement, we're neglecting the negative one. So S is the 4.85, and that's going to be in inches as well. Now I kept the inches in this particular problem, but a lot of times in math class, we don't even include the units. We put them in at the very end. But if you're in a science class, physics, for certain, you're leaving in your units. I don't know a physics teacher that doesn't have you leave in your units, but in math, we're like, yeah, we know what those units are. We're not going to keep them in there. It makes a mess for us. But I have them in there for now. So 1.8 times 4.85 is 8.73, and then times pi inches squared. So when I actually multiply by pi, and I'm going to get this out to 3 significant digits, so it'll be 27.4 inches squared, and that's my lateral surface area. Now I use the approximate, but you could still use equal. I'm not going to take off either way. That's what we've rounded to. It's 3 significant digits there. Any questions with lateral surface area of a cone? Be ready to find that triangle, that right triangle, to help find maybe a leg, which would involve maybe a radius or a height, or finding the S, which is the slant side. Okay, on to our last example for the day. Now, your diagram is a little bit, you know, it's fuzzy, but you can kind of get the idea. And you have 2 slides for this, and you have a whole blank like box. So, and we don't need all that space, but don't worry about trying to squish it in there. So if you need to redraw something or label something, that's fine too. So Eastern Propane sells a 500-gallon commercial propane tank. The tank is in the shape of a cylinder capped by 2 hemispheres. So we have a cylinder here, which would be in this spot here, and then we have 2 hemispheres, which together make a sphere. So hemisphere means like half a sphere, but together they're going to make a sphere. So find the volume of the tank. So our tank is 9 feet 11 inches long, and then the diameter is 37.5 inches. This is another, and we want the volume. I'm going to put it in here, volume in cubic feet. This is another scenario where we have mixed units. So I have inches and I have feet. We want our final volume in cubic feet. So let's convert this 37.5 inches to feet. Let's take care of that first. I just can't look at it any further. I want it in feet. So I can write in here because it's gray and it's fine, but right above your example 3, I think you can write it right up here. So 37.5 inches, well, converting it to feet, 1 foot is 12 inches. So using that conversion factor, I can divide this by 12 and I get 3.125 feet. I'm going to label that as 3.125 feet. That makes me feel better. Now this tank, this tank's whole length is 9 foot 11 inches. So I'm going to kind of like cut where my hemispheres are. These 2 together are going to be 1 sphere. So when I'm trying to find the volume of the tank, I'm going to need to find the volume of the cylinder in the center, right here, plus the volume of the 2 hemispheres, but together they'd make a sphere. So the volume of the sphere. So I'm going to need those 2 things. So the volume of the cylinder, if I want to write down the formula for that, what is the volume of a cylinder's formula? Anyone want to give it? You can refer back to the slide that had it.
V equals pi r squared h.
Yep, you got it. So the volume of cylinder is going to be pi r squared h. Now the volume, that would be the inside here. We'll use that information. So I'm going to need to know my radius and my height, and we'll talk about that in a minute. And then we need the volume of the sphere. Volume of the sphere, one of my favorite formulas. I don't know why, I just love it. It only has one variable in it. Does anyone have that formula? Feel free to look it up. Just read it verbatim.
V equals 4/3 pi r cubed.
Yes. So looking it up or referring to it will help you, kind of get used to writing it down and looking at it. So those are the two that I need. So I'm going to need a radius. Well, thinking about, let me start with finding the radius. So I have a diameter. The diameter I have is the 3.125 feet. So if I want the radius, I'm going to change my color here. I don't know what would be helpful. Maybe this color. This radius would be half that. So it'll be 1.56, we could say, feet. So that's going to help me. So I know my R is 1.56 feet. Now my height, and that radius is going to be true for my cylinder formula, and that's going to be true for my sphere too. Because the base of the hemisphere, that flat surface of the hemisphere is actually the flat surface of my base of my cylinder. If I'm thinking base, I know the cylinder is kind of sideways, but that cylinder. So I really do need this distance here as well. That will be my height. I have the height of a whole tank, but I don't want 9 foot 11 inches for that whole tank. So I need to subtract the radius for both sides. So I need to subtract 2 radii to get this. I don't know why, but okay. So it would be the 9 foot 11 inches. Now I have these in decimals, so let's convert this to a decimal. So 9 foot 11 inches. This is 9 and 11 twelfths. You write that as a decimal. 11 divided by 12 is 0.916 repeating. So I'll write this as 9.62 feet. And then I want to subtract 2 radii for the height. So it's going to be 9.62, subtract 2 of these for a whole diameter. So we can just subtract the 3.125. So 9.62 subtract 3.125 would be, I'll say 6.50 when I round it. Now, I'm rounding to 3 significant digits as I'm going. You might be keeping out more digits. You might have 4 digits, 5 digits out, which is fine. And then I'll follow your work. So if we're off a little bit from each other, I will know what you've written down because you're going to give me all the information you're using. You're going to show me you've been using 3 significant digits throughout the whole problem. So I should know your answer should, be rounded appropriately after that. Or if you kept out more digits, you might be slightly different. Okay, so now I got the height and I've got my radius. So let's go down here and plug in. So our volume of our cylinder we know is pi r squared h plus 4/3 pi r cubed for the volume of a sphere. And before you just write it like this, make sure that your radii is referring to the same measurement, which it is in this case. So we're good to keep it the way it is. So we'll have pi, the radius being 1.56 feet. I'm going to leave off the units though, because it's going to get cumbersome. We'll put on the units at the end. So the radius squared and then the height would be 6.50 plus 4/3 pi, and then the radius is 1.56. All right, let's go ahead and type this into our calculator and see what we get. Everyone do it because I want to make sure that I don't type it wrong into my calculator. And round to 3 significant digits. And when you get it, send it to me in the chat so then I know that you've all tried it. I have 56.2. I'm wondering what might have been off by your calculation. You're off by 4. Multiple 4. No. Oh, maybe you did a 1/3 pi instead of a 4/3 pi. Maybe not. It still wouldn't be the problem. Yeah, so I have 56.2 cubic feet. So let's go with that. $56.2, sorry. Okay, so what did we ask to find? We're asked to find a volume, so we did. We found the volume of the tank to be 56.2 cubic feet. Okay, the next slide. So this says propane expands about 200. Oh, you thought this was my bad. All right, propane expands about 270 times in volume when it goes from liquid to a gas. So 1 gallon of liquid propane equals 36.4 cubic feet of gaseous propane. All right, so it looks like we have a conversion there. So let's convert the volume in part A from cubic feet, and that is liquid, that's what we found, to gallons of propane to see how close it comes to the of gas. I'll say gallons of gaseous propane, let's say. Let's see if it comes close to that 500-gallon claim. So if you look back at our original problem, it said they sell a 500-gallon commercial tank. So, and at part A, we found it to be 56.2 cubic feet. And then we're told 1 gallon of liquid propane equals 36.4 cubic feet of gaseous propane. Okay, so this is liquid. And as the volume increases 270 times, let's do 56 times 0.2 cubic feet times 270. So if we do that, 56.2 times 270, we get 15,174. And 1 gallon of liquid propane equals 36.4 cubic gaseous gaseous amount of propane, I guess. It's hard to say, but that's what that is. So if I wanted to see what this is in gallons, I would divide by the 36.4 because 1 gallon of liquid. So if I divided that by 4, I get 416. .9. And this 416.9 gives me the gallons of gaseous propane. That is not 500, is it? Another way to look at this was, okay, well, I've got cubic feet. So I have 56.2 cubic feet of for volume. And I want to get it to gallons. What is that in gallons? Well, 1 cubic foot, I know the conversion for liters, looking at our table for common unit. So 1 liter is 1 cubic foot. And then I could tell you that one gallon, if I want to get it to gallons, is equal to 3.785 liters. If I did this, I'd cancel my feet, cancel my liters. I would have 56.2 divided by 3.785. I would get oops, I didn't mean 1 liter here. I'm at 28.3. I'm like, we're getting really small numbers. So actually, let me just erase that. 1 liter is not 1 cubic foot. It's 28.3 liters. And then 3.785 liters is 1 gallon. So we would do 56.2 times 28.3. It's 1590.46 divided by 3.785. Give me 420. So either way I do it, this is similar, right? I mean, we just rounding, it depends on where we're rounded along the way. Is this claim, this 500 gallon tank claim correct or accurate? You're going to say no, right? Because we ended up with only 420 gallons. So the claim is not really accurate. So again, we approximated, we said it's about 270 times. So I multiplied by 270. And then we said, well, it takes 36.4 to equal to 1. So I've converted it down to 416. And I said, well, what if that's like not a good estimate? I still converted my cubic feet to gallons and found it's 420 gallons. So it's not really what it's saying it is. Anyway, all right, so that's the end of that problem. Any questions? So a lot of our problems that we're going to be doing, these word problems or these applications when it comes to geometric figures, of course, we're working in a vacuum. Of course, everything's going to be perfect. Every measurement is going to be as close. I mean, we've rounded our measurements, but we're not going to talk about like any waste, you know, when we're trying to create the shape or whatever, but you might have to do some calculations, like in this case, to find a side. You might have to use your knowledge of like how to deduct what is this measurement here, which we found it to be 6.5. That was our height there. But we had to realize that this was a radius and this was a radius. So we had to subtract that to get the height of that cylinder. So it's going to be using your common sense a lot, which is wonderful. A lot of you like to use that. You're tech people. You are really interested in applying your math and not wanting to just work in theory. So you'll probably do okay with that. So make sure that you're setting it up, and you might have to like label extra things. You might have to try another way. Like in this example here, I was like, that doesn't seem right. But then we're like, well, let's try it another way. Let's see if we can convert it. And it still comes out to about the same. So they're really not claiming this correctly by saying it's a 500-gallon tank. All right, so your homework, I already mentioned at the beginning of class, your homework is going to be section 2.6, that's it. And then make sure next week when you come to class, you have chapter 4 ready to go. Does anyone have any questions? Kind of an odd day with my computer and camera and whatever tremor I felt, that didn't happen where you are. You're all good? All right, so if you're good, you can go ahead and sign off. Stay on if
Alright.
you have questions.
Thank you.